Imagine opening a jar of honey that was made before the pyramids were built, before the invention of writing, before bronze tools. In 2015, archaeologists excavating tombs in Georgia made a discovery. They found jars containing honey, not fossilized honey, not honey residue, actual honey, and it was perfectly preserved. The honey was older than King Tut, older than Stonehenge, and here's the part that confuses scientists to this day: it was still technically edible. You've probably heard someone say, honey never goes bad. Maybe you've seen an old jar in the back of your cabinet and wondered, should I throw this out? Most foods have expiration dates. Milk turns, bread molds, meat rots, but honey? Honey sits there, year after year, completely unchanged. There's a reason for that. And it's not magic, it's chemistry, it's biology, and it's the incredible work of bees. It starts with nectar. Bees fly from flower to flower, sipping up a sweet liquid produced by plants. This nectar is mostly water, about 70%, with some complex sugars mixed in. But here's where the magic begins. Inside the bee, an enzyme called glucose oxidase goes to work. The bee carries the nectar in a special stomach called a honeycrop, and during this journey, the enzyme starts breaking down the complex sugars into simpler ones. Back at the hive, the bees regurgitate the nectar into honeycomb cells. But it's still too watery, so the bees do something remarkable. They fan the nectar with their wings. Thousands of bees, working together, creating airflow that evaporates the water. They reduce the moisture content from 70% down to about 17 to 18%. Now the honey is thick and golden, but the chemistry is just getting started. Remember that enzyme, glucose oxidase? When the honey gets diluted with even a tiny bit of water, that enzyme produces hydrogen peroxide. That's right, the same stuff you use to clean wounds. Honey essentially makes its own antiseptic. On top of that, honey is highly acidic, with a pH between 3.2 and 4.5. Most bacteria cannot survive in that environment, and because the moisture is so low, any bacteria or fungi that land on it literally dry out and die. They cannot grow without water. 3 layers of protection. Bacteria doesn't stand a chance. But honey has one more trick. It's what scientists call hygroscopic. That means it attracts and holds water molecules from the environment. Wait, if honey pulls in moisture, wouldn't that eventually make it wet enough for bacteria to grow? Yes, and that's why sealing matters. When honey is processed, it's heated slightly and strained to remove impurities. Then it's sealed tight. If the seal is perfect, no moisture gets in. The honey stays exactly as it is, forever. But if moisture gets in, if you leave the jar open on a humid day, honey can ferment. It's not the honey going bad. It's the honey reacting to the water you let in. Which brings us back to that discovery in Georgia. In 2015, archaeologists found jars in ancient tombs dating back 5,500 years. Inside those jars, honey. Not honey-flavored residue, not fossilized crystals, honey, still thick, still golden, still chemically honey. Tests confirmed it was non-toxic. In theory, you could eat it, though most archaeologists politely declined. So the next time someone tells you honey never expires, you'll know why. It's not a myth, it's not an exaggeration, it's chemistry, it's biology. It's thousands of bees working together to create the only food on Earth that can outlast civilizations. Just make sure you close the lid. Do you keep honey in your kitchen? Have you ever found a jar that was years old? Let me know in the comments. Thanks for watching the Fact Atlas. Stay curious.